Very nice, very nice. Hello and welcome to the Great Egg Race, which, as you can see, this week has a musical motif. Now, Terry Pamplin, the man behind the recorder here, is our special guest judge. And here, waiting to explain this week's problem to our three teams, is the principal judge, Heinz Wolf.
Music without tears. What pocket calculators have done for children's arithmetic, we hope to do today for the early musical efforts. The problem is to construct a transportable machine which will play one or two recorders just like the one Terry has been playing now. The sequencing of the notes, of which there have to be at least 4 different ones, and the provision of the blow will have to be achieved entirely mechanically. Power can be applied manually, so we will look more favorably on machines which contain stored power. Marks will be awarded on the basis of being able to play a recognizable tune for 30 seconds and on the quality of the musical rendition. Teams, go and compose your solutions now.
So that's the problem. Now, as usual, the teams are each given a selection of things to choose from to make their device. Some are admittedly more useful than others, but they could well surprise us by using even the most obscure items. I mean, things like coat hangers or cheese graters or, well, even knitting needles. So now let's meet the teams. And first, from St. George's Hospital in London, we have Dr. Michael Hammer, John Ramsey, and Anthony Gibson. Next, from the University of Oxford, Department of Educational Studies, we welcome Cliff Denton, Dr. John Shore, and Keith Postlethwaite. And our third team is from the Institute of Occupational Medicine Ergonomics branch and consists of Andrew Nicol, Colin Talbot, and John Pevick.
The problem is going to be to provide enough air to run for 30 seconds. So I would have thought we want to use the one which has the least air consumption. Do you think that's reasonable?
Yeah, the higher one.
Yes, which is clearly the higher one.
Mike, can you play a recorder? 20 years ago.
Oh, God.
Can you play us a tune just so we know what sort of range it is?
We ought... Oh, gosh. We clearly got one
an echo. The mating call of the lesser spotted recorder,
yes,
obviously.
I think this uses more air.
Might make a nicer sound.
What do you want me to do?
That's the same note, is it?
That's in tune, yeah. That's the awkward transition because it's taken them off.
Wait a minute. So we can play how many notes?
You can play.
Play a sequence of notes from there. What's the next note up? Oh, that comes off.
What about the air source itself? Are we going to have some sort of a cam and bellows arrangement?
Or we could use the bicycle pump, trying to drive that somehow.
We could indeed, yes. Yes, that gives
the
small
source of
volume,
energy
high
that we've
pressure,
got
doesn't
stored.
it?
Put it through our smoothing capacitors.
Yes.
In your
yes,
mind.
yes. I mean, one
With
can
the
always
timing
use
for
one of those
economy.
rubber gloves as a bellows.
Terry, am I right in thinking that there are really two quite separate control problems they're facing?
Yes, because it's very important that in music that you change the notes and you also have rhythm. So they could get a tune by just lifting fingers on and off to change the notes, and they get this. But if they actually tongue the notes and switch them on and off clearly, they get their rhythmic sound.
So in fact it's really rather more difficult than I thought, because the modulation of the airflow has to occur synchronously with the selection of the notes.
That's right, they have to articulate each note and start it clearly and precisely. They get a tune without that, but it does help the music.
And another problem that they will have, of course, is raising the wind. And I try to get some estimate of how much flow they actually required by using myself as a living gas meter. And I find that my vital capacity is about 4 or 5 liters, and I can maintain a continuous blow for about half a minute. So the volume of air that it requires of the order of 4 or 5 liters.
Yes.
But the kind of means they've got of producing this is this plunger here, which is actually asking to be used as a piston in one of those large pieces of drain, of drain pipe. Or they might perhaps inflate one of these polythene bags. Now, how about making fingers? How would you go about this?
Well, I think you can actually simulate a finger by, say, using knitting needles which will come down over the top of a hole with a little pad on the end and simulating a finger.
And they've got pad materials.
Yes, we've got various forms of rubber or plastic pads and knitting needles and so on. But the other way they could do it would be rather like a player piano control system where a sheet could cover all the holes and then you could just punch holes when you wanted them in the moving sheet.
And they do, of course, have all sorts of materials, like this wallpaper here and greaseproof paper, and perhaps even the material from the plastic.
Yes, they could cut a
plastic
strip
bag.
out of the bin bag and use that as a strip, yes.
So it doesn't really appear that they're short of materials. It's really the technology which they're going to use.
I think it's the combination of those materials, yes.
Well, we have to see how they get on.
Yeah.
You seem to be working on some sort of hydraulic principle. What's the idea?
Well, the idea is that water from the tap forces air out of the can through that tube to sound the recorder.
Is that going to make enough air to sustain a note?
Well, we're experimenting with that.
We're worried whether a can full is enough, but if not, we've got a bucket.
Oh, good thinking. Okay, if you do get enough air out, how are you then going to cover up the various notes in order to produce a tune?
Well, we're aiming to use a pianola style, where you have a continuous band of, in our case, wallpaper with slots in, and as the slots go over, so they make the notes.
This sounds great in theory.
Oh, yes.
I look forward to seeing what happens.
So do we.
Okay, good luck.
Right. So we now start making the seals.
Yeah, so that means cutting this off, doesn't it?
Yes. Well,
And also means drilling this cork.
well, you drill the cork, I'll cut
Okay.
that off and get going this end.
Mike, I wonder if I interrupt you for a minute. This looks very interesting. Can you tell me what you're doing here, particularly on this rig? What purpose is it going to perform for you?
Well, basically, we're trying to have a drive system.
Yes.
Two cans with the rubber being pushed across it.
Right.
A recorder here. We're going to
Right.
have 2 cans.
Uh-huh.
And we're going to use 4 holes. That'll give us the right number of notes for the tune we intend playing.
I see.
These will be driven across, and rather like a pianola system, we'll have holes or slits.
You'll have holes or slits in the rubber
in
itself?
the rubber, yes.
And that'll be supported up on your rig here, will
Yes.
it, when you've got it
There'll be
completed?
the power source is the.
Oh, I see. Yeah, but I better let you get on, pal. Go over and see how Tony's getting on, because I think he's doing something rather interesting over here with this large piece of pipe.
Well, we're trying to make a sealed container apart from these 2 tubes.
Yes.
We hope to run water in through one tube, displace air inside, and then use the displaced air to
play the
recorder.
instrument.
Yes.
Yeah. And what have you got at the other end here?
Well, sealed in the other end is a common or garden sink plunger.
Oh, and that just forms a seal, does
Which
it?
is just pushed in there. It's up inside of here, but just to form a seal.
Form a seal on the bottom.
On the bottom where the bulk of the water pressure is going to be acting, so we want a very good seal down there. And I found the lid off this container of material here, this plaster stuff. It fits very nicely on the top of this tube, so I'm just sealing it with black insulating tape
So
just
that's
to make
working
sure
out
it's...
pretty well then, is it?
Well, I
now
hope
for the
so. We
seal?
haven't tested it to see whether it's airtight or not, but I do hope
Super.
that it's going to...
Right, well, I won't take any more of your time. That's absolutely fascinating.
It's nice to
Very
have a
thanks
rest,
there, Tony.
actually. It's a little warm.
Thanks very much.
Andrew, what scheme are you going to use to cover and uncover the holes?
Well, we're using the musical box scheme based on this drum.
Which is a piece of drain pipe.
Which is a piece of drain pipe with a couple of flower pot holders in the ends.
That's very lucky.
Very lucky indeed, because they do have little pieces which will give us the centre for the drum, because obviously it has to be accurate. We shall have pins on here, arranged according to the map which I'm drawing out at the moment, which we can put round.
Can you have a
Yes.
look at the map?
Yes.
How many
that's,
tracks? How many tracks are there in effect?
There are 5 tracks.
So you can modulate 5 notes.
Yes, and plus the fully closed note, which
Yes.
will give us 6 notes altogether. In fact, basically we use 4 here and 2 extra ones at the end.
Now,
And then it goes round again.
This map looks bigger to me than the circumference of your drum.
Yes, in fact, I'm drawing out the scale model here. This one will actually just fit round it, and using this we can just pinpoint the holes and positions of the pins.
Some of the times open appear to be much longer than could be given by a single pin on here.
That's right, yes. We're going to put pins at the beginning and the end and just join them up over the top.
That's very elegant.
Just to keep the fingers open. We're using fingers pivoted to to rest on the recorder.
Right.
With a piece of rubber at the end.
Right, thank you very much.
Okay. There we are. It's very easy to make a mistake right at the beginning, and that's just what I've done. I think I'll have another colour for this.
Terry, when we defined the problems at the beginning, we mentioned the modulation of the air supply. Now, none of the teams seem to have attempted to do this.
No, they haven't looked at this one at all. And tonguing or articulation, it's very important to give clarity and shape to the music, and they haven't tackled it at all yet.
The other thing which concerns me is that at least one of the teams is going to use a drum of this kind.
That's right, yes.
With raised portions to operate levers. Now, unless the drum is really rather large, the actual rate of rise and fall of the lever seems to me to be inadequate to produce a crisp control of the notes.
Yes.
It's likely to be the problem.
Well, this is a great problem, because if they have no articulation, no tonguing, and the levers move very slowly, then it'll be very blurred. Now, here we've got a model that was made by one of the trial teams, and this is how it works. The fingers rest on the recorder, and then they turn the drum, and then the fingers move and open in the holes in this case until another piece of string comes up and then places the pad back onto the recorder again. And this is a system one of the teams certainly is using.
Now, if one uses a drum, one has of course a limited circumference.
Yes.
If one uses the alternative possibility of using a broad paper tape, for instance, and having holes in the paper tape, which coincide with the position of the holes on the recorder, then it ought to be possible to run this tape at almost any speed you like, and so get much crisper opening and shutting of the
Well, you can, because you can use any length of paper, and then the speed can be varied at will, where it's restricted here. And that slow movement can actually flatten notes if you slowly close them, so it cuts out the clarity of the music.
Now, a problem which I think all the teams are facing is how to actually provide the drive. They all seem to be attempting a power drive, possibly using the mixer.
Yes, yes.
I would feel this was misguided, probably, wouldn't you?
I see this as being the biggest problem at the moment. The greatest lack of control, I think, is going to come in this particular area, yes.
Well, this is the analysis of the problem as it stands at the moment. Yes, it's the pin itself. Well, the blue team at half-time seem to have got a bit of machinery which is not far off ready to have the belt put onto it. I wonder, Terry, how they're going to keep that belt taut, because it seems to be an essential feature.
Yes, this was one of the worries. That far rolling pin, unfortunately, isn't totally concentric, so they were going to get some slack on the belt, and with a wide belt, this could be a problem.
Because am I right in thinking that in order to stop the hose up, you really have to stop them up?
That's right.
Absolutely.
And if the belt is tight on one side and loose on the other, it will buckle and then lift off of some of the finger holes and cause notes to play when they're not wanted.
Well, you must admit, it's quite elegant the way it fits over those rollers.
Well, I like the engineering, actually. Apart from that one rolling pin problem, I think it's pretty robustly made.
I think they will either have to install a jockey pulley.
Yes.
Or perhaps they're going to have a weight in the bottom.
I wondered, when we saw the sag there, it gave you the hint they might be dropping it down with a tensioning device.
Because their belt is very much longer than twice the distance between... Oh yes, you see they've got to plait it over a roller, underneath the recorder, over the other roller.
That's extremely good, because that'll keep a good grip on the recorder by gaining that.
So my criticisms are quite unjust just now.
Obviously the design has taken that into account, yes. But it's a nice robust piece of engineering.
In sharp contrast with Oxford, here we can see in the red team a porcupine-like drum being made, which I suppose is going to move the fingers up and down.
It looks very much like the musical box principle here, and the thing I like is it's strongly made, and it looks like it'll be quite accurate. It seems to be quite a precision job.
I think it's well centered, but of course they have the disadvantage of having used a small drum we were discussing earlier on. But we can see the framework into which this whole thing is going to be fitted. That wooden channel they seem to have made.
And that looks like that could track quite accurately, because it looks a strong frame.
And we haven't yet seen the pivots. The pivots for the fingers would appear to be the knitting needles which have been put across.
I think so, yes. It looks like it's just roughly positioned at the moment. But it's going to be quite positive. It's all within one framework, the recorder and the drum.
We don't want to get it on the rubber band surfaces.
Yes, well, the belt there is a double belt, and I think it's going to pass round the two drums and up over the recorders, and they're obviously going to have a tracking problem to make sure that it actually goes over the recorder accurately without missing the holes as they intend.
I think they've actually joined the two strips of rubber together with a long length of sticky tape, so their belt, I think, is going to be, we can see the yellow, the green sticky tape joining the two bits of rubber, and the hose, which are going to uncover. So it is going to behave as a single belt, I think.
Yes, that's good. And obviously they're going to need a tensioning device there. I haven't seen one yet. They've got the two drums and the recorder, but that's obviously a very elastic belt they've got.
Yes, and they are, of course, forced to having the belt go over the top of the recorder, so they can't use a rather cunning trick of the University of Oxford of weaving the belt underneath the recorder.
No, that's right. And it could be quite prone to slipping in either direction, I would think, unless they've got them absolutely aligned together, the recorder and the two drums.
Robot recorders are pretty rare on the domestic scene, but player pianos at one time were quite common.
Piano is usually played by pressing the key. But with a player piano, the suction is created by foot pressure on some foot pedals. This sucks the air out of the piano, and through a control system it makes the hammer hit the strings. And the important thing to look at here is this tracker bar. There's a hole for every note on the keyboard. And the moment one of these holes is uncovered by a punched hole in the paper tape here, it makes a note sound. And the paper tape is driven by this air motor. So that's the basic mechanism of the player piano.
Well, the teams now have just over half an hour in which to finish their work, and they have been working very hard. Remember, what they're trying to do is to make a musical instrument which is based on a recorder, or they can use two recorders if they want to. But that machine has to be able to play a tune which is going to last 30 seconds and contain at least 4 different notes. And the notes have to be powered and selected by mechanical means. Well, we've been getting some very strange noises from around the studio, so let's see how they're getting on with it.
Well, half an hour to go, gentlemen. Any final snags?
Well, we're just sort of finally adjusting it to get it all tracking correctly, and we needed a new pressure on there. So there's various little trims to do, but
It's all taking shape now,
we're
is
hoping
it?
for the best, yes.
Jolly good,
The
right.
hardware and the software have come together at last.
We wait for the music.
So, that's there. At the moment we're trying to get the correct weight down the bottom here.
Ah, right, to keep the attention.
Yes. That's going okay.
Let's see if we can make music.
Yeah.
You seem to have reached a rather critical part of the proceedings. In fact, your first test. Your reservoirs are discharging. But
Quite got enough angle. We're not including the holes completely, I think, too.
you appear to have two problems. One of them is the lack of friction between your drums and the belt.
Yes, indeed.
And the other one to compensate for the fact that the recorder isn't parallel sided.
Yes,
Yes,
yes.
our retorts aren't
And we've got just enough time to sort those out.
Well, hello, Andrea. How's it going? Are you getting somewhere near a test run yet?
Somewhere near. I would give it another 2 or 3 minutes probably.
Near as that?
Until we've made the final adjustments, yes.
Right, so
Yes.
it's really up to the last stages then?
More or less, yes.
The hedgehog's under control now, is it?
I believe so, yes. It depends. There's a little bit of more spacing to do, but we're more or less there.
Good.
Yes.
Oh, that's
yes,
marvellous. We look
yes.
forward to the musical results then.
So do I.
Thanks very much, thank you. Thank you.
Right.
Right, so we just hold it in the pod. We can adjust. We don't need all that, actually. We can make
It's going the wrong way around.
Put too much pressure on. Yeah, the bag seals itself, does it?
Yes, we are going to need some more rubber band on here, I think, too. We're going to need
Not
some
got
more.
enough ballast. I don't think it's going to
Well, it makes a lovely noise, but there's no...
These three recorders, which we see here, are the range which a school would normally use. But you, Terry, can complete the consort, I understand.
Well, I think I can, Heinz. I've got some lovely instruments made by Kenneth Collins, and this is a bass recorder that has some rather nice notes. And just slightly differently to that one, in complete ivory,
So the 3.5 hours is now up, and it's time for our concert. Now, the first team who are going to play for us is the team from St. George's Hospital. But just before they start, I think Heinz had better explain how the judges are going to be scoring all this.
Well, 50 marks for producing musical notes, more or less, for 30 seconds. An extra 25 marks for musical quality and ability to recognize a tune. That's ability on the part of the audience and ourselves to recognize a tune. And a further 25 marks for entertainment value, impudence, and anything else which happens to cross the judges' minds. Now, gentlemen, are you ready to raise the baton?
Just a few. 10, 9, 8, 7, 6.
Your 30 seconds are starting
now.
Halfway. They're playing it backwards now.
It doesn't make any difference.
Right, 30 seconds. 30 seconds, gentlemen.
You don't expect us to stop it too.
Well, I think we must admit that they have actually produced musical notes for approximately 30 seconds. I think reversing halfway possibly has detracted a little bit from their score.
Cunning, yes, yes.
So how would you agree to say 45?
I think that's fair enough, yes. Because there is an early technique of playing music backwards, which is authentic, so I think we can allow that.
Right. 45 marks on that score.
I wonder if there's anybody in the audience who can actually let me know the name of that tune without any help from the team here. Very good try. So I'll give you a slight clue and see if you can guess it from mine. You probably won't, that'll be terrible. Anybody name the tune? Now please, anybody name the tune? No, well, that's it. We'll cut your prayer, Jacques. Thank you very much. We'll come back for the mark very shortly then. I think we're going to move on to the next team.
That is absolutely wonderful. I never knew that Frere Jacques was a sort of musical palindrome. Anyway, we move briskly on now to the Institute of Occupational Medicine. What do you gentlemen have for us?
Gentlemen, are you ready with your porcupine or hedgehog machine? Significantly different principle from the other. Well, wait for it. Your 30 seconds start now. Stop. Your 30 seconds are up.
We've gone on forever.
Well, well, Terry, they didn't actually ever go backwards at any time.
No, that's very true. No, very true.
On the other hand, they had to have a certain amount of what we might call digital assistance.
Little assistance, I think, yes.
So how would you take, say, 40 for them?
I think that'd be very fair, yes. And now I'd like to ask our audience, can you name that tune?
Third man.
The third man.
It doesn't add music at all.
I know. It was so clear, wasn't it, really? Anybody can follow it. Does this help at all? It probably won't. Which is just the same as... But the timing is different. Well, can you name that tune? Yeah, thank you very much. Yes, that's right. They've got the tunes. It's the audience is all right.
Well, our audience have one more shot at getting the name of the tune, because now it's the turn of the team from Oxford University.
Gentlemen, you have a form of tape recorder. Would you like to... Are you ready to start? Yeah. Well, your time for 30 seconds starts now. Stop the clock.
We can go on.
Keep going. Right, so your 30 seconds are over. Not a dry eye in the house.
My eyes are worried about it.
On terms of endurance, bearing in mind for time out, which wasn't strictly your fault, so we gave you some extra endurance for that, I think we might give them, what, 42?
Yes, I think that's a fair mark, yes. Well, ladies and gentlemen, here is your chance. The name of the tune was... Thank you very much, ladies and gentlemen. It was the National Anthem.
So at the end of the testing stage, the leaders so far are St. George's with 45 points. But that's not the end of it, because the judges can still award marks for skill and ingenuity and musical appreciation.
St. George's scored 45 for sheer musical endurance.
And 5 marks for musical quality.
And 12 marks for entertainment and impudence, which provides a total of 62. Now we pass to Oxford University. They only scored 42 for musical endurance.
But they pulled it up with a musical score of 20.
And for entertainment and general engineering standard, another 15, provides a total of 77. And finally, the Institute of Occupational Medicine scored 40 for endurance.
And 10 marks for musical quality.
And they really achieved a rather high standard of engineering ingenuity and scored 18, which gives them a total of 68.
So it looks as if tonight's winners are Oxford University with their memorable rendition of the National Anthem. Congratulations to them, and of course to our 2 runners-up, and many thanks to Heinz Wolf and Terry Pamplin for judging the competition. We'll be back again next week with another great egg race problem and 3 entirely different solutions to it. So we'll look forward to seeing you then. Until then, good night.
And next week's teams pit their wits against each other and the clock as they set their sights on a rather unusual target. The Great Egg Race next Thursday again at 6 o'clock. Now on BBC Two, Sorry Mate, I Didn't See You looks at the new Part 1 ministry test for motorcyclists.